Hey everybody, Raymond here with another video. Got a Neo Geo on the workbench. You'll have to excuse the background noise a little bit. I've got a TI-99 4A in the background here that I'm running some burn-in tests on for donation to the National Video Game Museum. So that'll be going on in the background while we do this video. Alright, so what I have on the bench today is a Neo Geo board. This is an MV4. It came in with the symptom of, or the described symptom of being dead. So put it on the bench. It's a 4-slot, so pulled the top board off after discovering it wouldn't run with a cartridge and went to look at the battery, and I already took it off, but you can see on the battery here that there's some nasty stuff, some of that grunge you get on the battery when it starts to leak. And when you go to take it out, you can flip it over and you can see that the bottom of the battery actually looks pretty decent. A little bit of stuff on it, but not a whole lot. But if you look where the battery was, it's a whole nother story. And the problem is you've got traces that are going right up under here, and these traces carry the data from the cartridge over to some bus buffer, or some latches, some 74 AS245 latches on the board. Find where my finger is in the viewfinder here, to these two, and these traces are just roached. So what will happen is these traces will be bad, so you have to flip the board over and solder some jumper wires from here down to either the points on the bottom of the board where these vias come through, or you snake them across to these two chips. So I'm going to turn the camera off, step back, and do some trace patching and some cleaning up of this area over here where the battery was. Be back in a little bit. Okay, so we got the battery area cleaned up. To do this, you can use a well-calibrated fingernail, or you can use a small wooden spatula, something like you'd use for carving modeling clay, to help scrape this stuff up off the board without damaging the traces. Now you can see where the negative lead for the battery was, and what happened is there are 8 traces here. They're grouped in 2s, 2, 4, and then the 6 and the 8 are up here towards the edge of the connector. The silicone that they had on this helped cover the traces and protect them, but this area up under here that wasn't covered with the silicone got the brunt of the battery leak. So now we've got to go in and trace these out from the pins here down to where they come out to this row here that goes diagonal, and this row down here that goes diagonal on the bottom side of the board, and then determine which traces need patching. Then we'll use our trusty 30 gauge Kynar wire wrap wire to make the patches. So back in a little bit. Alright, so we're looking at the bottom side of where the battery goes. You can see the positive terminal here, the negative terminal up here. We've got the connector right next to it where all those traces run from around that battery. And then down here we've got the traces that map to those. So the 4 up here go to this end, and these are for the address bus. These, I'm sorry, the data bus. These go down to the LS245s. They could be AS245s or ALS245s depending on the board. Then these 12 are the remaining lower 12 data bus bits. So there were no problems for the first 3 here, but they all traversed under that battery, and the first 3 for the address bus were dead. So if we follow those back over here, those go to this diagonal piece and this diagonal piece, and it's every other one. So 0, 1, 2, 3, 4, 5, 6, 7. And they come down here to this 74 LS244, and I circled where the traces go. The data bus for the LS245s, those first 3 come down to here. And we're just going to run our Kynar wires from here up and over to here and connect to these. Now the first 3 for the data bus weren't bad, but since they were right next to the 3 address bus lines that were roach, we're going to go ahead and patch those anyway, just because the battery damage is just going to continue eating away at those. I mean, you can clean it up as best you can, but you're still going to come back after some time and patch them, so just patch them and get it done with. Alright, so I'm going to go ahead and kill the camera and go in and put in some patch wires. Alright, we got it running. All 6 traces are patched.
Metal slug!
So we'll turn it back over and pretty it up. Right now there's just a bunch of loose wires on the bottom, and it's not real pretty. So we're going to go in and we're going to pretty it up. Okay, so we've got the wires tacked down, we've got the battery holder in place. We've replaced that pesky NiCad with a coin cell battery holder. We'll put the battery in it tomorrow. But the other thing is when you do that, you have to come in here and you have to yank out this 470 ohm resistor in here. This neuters the charging circuit, and then we can get the battery holder soldered in. I prefer to solder them on the back side of the board, just simply so that when you go in and you replace the batteries in these, that you can replace the battery without having to take the board stack apart. You know, these 4-slot boards, you've got a top board, and then you've got all the screws that go in through these connectors here that hold it together, and you got the screws that go into these feet here for the slots that hold those together, and then you got the metal cover that goes over them. That's a real pain in the neck to go in and remove when it comes time to change your battery out. So if you solder the battery holder on the bottom, works great. Sometimes the holes don't quite reach, so what you can do is you can bend the negative lead out flat, solder the positive hole or pin through the hole, and then take and solder the negative lead to the top of the pad. Just put you some RTV underneath it and let it cure before you put it all back together. And what you'll get is you'll get a battery holder that's nice and stable on the bottom of the board, and the ability to change out your batteries quickly. Just don't forget to take out that 470 ohm resistor to neuter the charging circuit. Now I'm going to let this sit until tomorrow, so I'll come back out tomorrow and we'll reassemble everything and show you the finished product. Alright, it's a new day. Everything's nice and dried out and set, and there we go. Got all the patches in place. We've got the battery in place. Everything's good to go. Let's zoom in here, take a little closer look. So wires are fastened down, connected to the 74LS244 for the address bus, and then down here for the 74LS245 for the data bus. So now our cartridges will work. Let's reassemble everything and put it on the bench for one last test. And there we go. One repaired 4-slot. We've got 4 cartridges in it. Everything is buttoned up, reassembled, and good to go. Now I did have to replace one foot on this. One of the orange feet was broken off in shipping. Not a big deal, it happens. When you ship these, you should take the metal cover off if you're going to ship them in for repair, and ship it without the metal cover. And then when you go to ship it, make sure you ship it upside down so the feet are up, so if the box takes any smashes in transit, that it won't break the feet off. Anyway, Metal Slug, another Neo Geo system resurrected, so hope you enjoyed.